Hello everyone, this is Professor Chan speaking from Math 1245. Today we're going to be going over section 2.3 and that is linear equations. Now this section here, some of you guys, actually I would say most of you guys would probably know how to do this already, but this is a quick recap. So hopefully this video should not be that much of a confusion to you. Okay, but let's just remember we have some basic things, okay? Make sure you look over a textbook, okay, because I'm going to quickly go over formulas that I'm assuming you know, okay? So just remember we have something called slope, right? We have slope, formula for slope is m is equal to y2 minus y1 all over x2 minus x1, right? So essentially the points of my y's over my points of my x. Sorry, change of y over change of x, okay? And remember, the formula that we tend to use is what's called slope-intercept form, which is y is equal to mx plus b. Okay, this is the one we like to use because y is by itself, and I already know my slope, which is my m, right? Remember, this is your slope, and then b is what's called your y-intercept. Okay. Now, we have a situation where we have sometimes they will not give us enough information to construct our slope-intercept equation, or y equals mx plus b. So we can use what I call a transitional formula called point-slope form, which is y minus y1 equals m times x minus x1. Okay? And so this point slope form is actually very useful to us because, like what I said before, we will be running situations where we might not be given enough information to use slope intercept form or linear or my default linear equation. So let's take a look at this equation here. Sorry, not this equation, this problem right here. So they give us a situation where we have a line going through the point 2 comma 5 and we have a slope of 3. So what I'm going to do is I'm going to do the following. I'm going to use this formula, y minus y1 is equal to m times x minus x1, because I know a point and I know my slope. And all I'm going to do is I'm going to plug it in. So I have y minus 5 is equal to 3 times the quantity x minus 2. Okay? And then all I need to do if I want to write in slope-intercept form, I'm going to distribute like this. Sorry, that is not 6, that is 10. Oh wait, that is 6. My bad. My apologies for that. And then you want to get y by itself, so you'll add 5 on both sides. So y is equal to 3x minus 1, and this is my answer. Now, I do want to make a small note to take that you might want to take in consideration. When you're working on MyMathLab, sometimes they do not actually want this form. They may potentially want it in this form. So when you're doing a lot of these types of problems on MyMathLab, just make sure you know, look at an example and make sure you know what form that they want you to do. Okay, but this is generally the one that is the most appropriate because obviously it's easy to graph this, right? I can throw this in my graphing calculator, right, for the following. Right, I can press this in. I can say y equals 3x minus 1, right? And then it's going to be easy for me to graph, okay? So that's why slope-intercept form, and remember when I say slope-intercept form, that is the equation when y is by itself is useful because it's just easier for us to graph by calculator and by hand, okay? Okay, let's do one more example. Let's look at number 2. Okay, just make sure you know how to deal with fractions. Remember the following. This is y minus y1 equals m times x minus x1. Remember, be very careful with your signs when you plug this in. So this is going to be y minus parentheses negative 1 equals 1/4 times x minus 8. Okay, so remember, when you replace a variable with a negative number, make sure you put in parentheses so that you don't get confused by the signs. So I have a double negative that becomes positive. Okay, make sure you know how to multiply fractions and add fractions. Okay, 1/4 x 1/4 times 8 is negative 2 because I do 8 divided by 4. That's 2. Remember, you can also multiply across and then divide later. And then I'll subtract 1 on both sides. And I have y equals 1/4 x minus 3. Okay. Now, let's also do a quick recap of the following, okay? You will run into a situation, sometimes you'll have slope that's 0 or slope that's undefined. You have to realize that, remember, this is a horizontal line. And an undefined slope means it is a vertical line, okay? I want to show this one to you because this is a common, tricky one that a lot of people struggle with. So horizontal, you could still actually plug in 0 and you'll actually still get the same thing. Vertical, you actually have to kind of visualize what's happening. So let's look at number 4 here. Now, notice I'm just kind of stuck because I can't exactly plug in an undefined, right? It doesn't make any sense. So the way I want to think about this is I want to think about my graph. And it's going through 312. I'm not going to write all the hash marks. We can pretend this is 312. Okay. And we also know that it is a vertical line because it's undefined. So it goes like this. Okay. So just a quick reminder, what is an equation dealing with a vertical line? When we have a vertical line, we always do the following. We do x equals some number. When it's horizontal, it is going to be y equals some number. Okay. So you need to be very mindful about that because that's going to help you. So in this case, I have a line going through 3 and it's vertical. So my answer is just going to be x is equal to 3. Okay. So that's the first half. Let's talk about the second half for section 2.3. Okay. So when you're doing point slope form, a lot of times they'll either give you something like this, or they give it to you in the form of 2 points, which is what we see right here. Okay. So they'll be like, find the equation of a line, and then they give you 2 points instead. Okay. So if you notice, right, you're like, that's going to be difficult because, right, we don't know slope and we don't know y-intercept. I also can't immediately use my point slope form because, right, I need slope to begin with. Okay. So what is the first thing we're going to do? We're going to actually find slope first. Okay. Now just remember, when you're doing this, label them before you start so you don't confuse yourself. Okay. Just make sure you're being consistent, right? Each point should be either 1 or 2 as a pair, right? So I'm not doing x1, y2 or x2, y1, right? They're both the second point or they're both the first point, and they come in pairs. Okay, so I'm going to do m is equal to y2 minus y1 all over x2 minus x1. So y2 is negative 10, and I have minus 5. And then negative 2 minus 3. Okay, for the following. Okay. And this will become negative 15 over negative 5. Make sure you always reduce, because if you don't, it's going to make your life a lot more difficult when you're doing these problems. Okay. And then just a quick reminder, right? If you guys don't remember this, is it actually does not matter which one is your y2 or your y1 as long as you're being consistent. So you could flip it around. You could do -5 minus -10. Sorry, 5 minus -10 over 3 minus -2, and you'll actually get the same results. Okay, so just keep that in mind. So once I find my slope, I'm going to essentially do everything that we've been doing before, right? So I'm going to do the following, where I'm going to do my y minus y1 equals m times x minus x1. So I'm going to do my slope, which is 3. Now here's the thing. It actually does not matter which one you use. You can use 3 comma 5, or you can use -2 comma -10. Okay? I'm just going to do 3, 5 because it'll be easier to manage because I don't have to worry too much about the signs. And then I'll do y minus 5. So I'll distribute. Then I can add 5 to both sides. And I have y is equal to 3x minus 4. Okay, so let's look at another example. Let's just do one more. Actually, let's just do 2 more. Let's get number 5 here. So I'm going to do the following here. Find my slope. So I'm going to do the following. Okay, so this will be -1/2. Okay. Then I can plug into either point, okay? And you just want to be strategic too, right? So you're like, which one would I use? And I've noticed here, because my x is 0, it actually makes things a lot easier, where I don't actually have to multiply it through as much. Technically, it doesn't really matter. But yeah, just remember, right, when you're doing a lot of problems, right, if there's a shortcut, go for it. So as you can see, this point here is probably going to be a little bit easier to use. So I'm going to do y minus 3 is equal to -1/2 x minus 0. And so x minus 0 is just x. So then I'll add 3 to both sides. And I have y is equal to -1/2 x. Okay. Yeah, and then one thing, once again, is you got to be very careful of horizontal and vertical lines. So if I look at number 7 here, notice the following here. If I do slope, which is y2 minus y1 over x2 minus x1, right? And I subtract, and I have 5 minus parentheses -2 over 4 minus 4, right? And I have 7 over 0, okay? Now, if you put that in your calculator, right, notice if you do 7 divided by 0, remember you can't divide by 0, right? That actually doesn't work out, right? And what is this? This is actually an undefined slope, okay? So you have to realize, right, this is a vertical line. And remember, we talked about we can't do that. So if I graph this, I have 4, -2. So I'm just going to do this really quickly. Sorry, 4, -2. And then 4, 5. Let me erase that. Okay. Right, I can draw a vertical line. It goes through those 2 points. So it's actually going to be x is equal to 4, because x is always 4. Okay. Okay. And you will run into a couple word problems, but it's actually pretty straightforward, okay? Now, when you're doing word problems dealing with graphing, you need to make sure you know which one's your X and which one's your Y. Now, they're being nice to us, and they kind of spell it out. They're like, oh, X is number of years service, and Y represents the monthly retirement income, right? So I'm like, okay, X is number of years, and Y is the income, okay? Now let's talk about this as well. Like, so Y is number of years X, Y, and Y is letter Y. It's the same as income, okay? So let's pretend they didn't give that to us, okay? So remember, Y is called your dependent variable, X is called your independent variable, right? Your book talks about this in the earlier sections, in section 2.1. So your Y is always dependent on your X. So a lot of times we say if X happens, then Y happens, okay? So if you think about it, it makes sense because the number of years that K works, right, dictates how much he gets paid, right? It's not the other way around. We don't say K made $60,000, so therefore he's going to work for 12 years, right? It doesn't really make sense in that context, right? So X is always kind of like, we call it your cause, and Y is your effect, okay? So if I look at part A, it says write a linear equation for this particular problem. The thing you should immediately realize, it says if he retires after 20 years, his monthly retirement income will be $2,450. That you should realize is actually a coordinate. So we're doing 20 comma 2450 because we said the 20 years is X, the 2450 is income, which is Y. And then it says after 20 years, he made 2450, so they relate to each other, their relationship. Okay? And then if I look at the next part, then I have 30 comma 2800. So when I look at my slope, I'm gonna make this one X. I'll make this one X1 Y1, and this one X2 Y2. So I have 2800 minus 2450 all over 30 minus 20. And this is going to be 350 all over 10. Again, make sure you reduce, and my slope is 35. And then I'm going to use my point slope form. Y minus Y1 equals M times X minus X1. So I have Y minus 2450 is equal to 35 times X minus 20. Sorry. Okay, so distribute. So that is 700. And then I'll add 2450. And so I have y is equal to 35x plus 1750, okay? And as you can see, that's not difficult, right? It's just the same thing we've been doing the past 15 minutes, okay? It's just in a slightly different context. Now, part B says, what will the retirement be for 25 years of service? Or sorry, the retirement income be after 25 years of service. We have to realize, what does a 25 years service represent? That is X. So all they're asking us is we're going to replace X with 25. So I'll just do Y is equal to 35 times 25 plus 1750. 35 times 25 is going to be 875. And we'll combine them. And this will be $2,625. Make sure you label because we're talking about in the context of a word problem. Okay, but that's pretty much it. Okay, this is just a quick review for several of you guys. You guys have maybe seen this before. Okay, but other than that, have a good day. We're going to continue on with section 2.4 in the next video.